Hi, good morning. I am JUPETH Serra, and I am a fifth year mechanical engineering student. Today, I'm going to discuss what is steam power plant, the concepts and calculations, some of the calculation of steam power plants. So let me share my screen. Right. So steam power plant, the concepts and calculations. So first, we need to identify the concepts of the steam power plant before we proceed to uh, calculations of the steam power plant. So first is we're going to define what is steam power plant. Number two, types of steam power plant. And number three, components of steam power plant. And last is the basic idea about the operating system of steam power plant. What is steam power plant? In the 7th century, scientist James Watt discovered the applying of the heat to water turned it into a vapor, and a lot of work could be done. Using the vapor pressure to rotate and lift it at the corners, later, on the basis of his theory, the steam engine and the thermal power plant were established. Thermal power plants are commonly known as the steam turbine power plants and steam power plants. So big thanks to James Watt because he discovered this kind of invention that we are very useful in today's generation that we're using right now. A steam power plant consists of boiler, steam turbine and generator, and other auxiliaries. The boiler generates steam at high pressure and high temperature. That's the purpose of boiler in a steam power plant. The steam turbine is the part of the steam power plant. The steam turbine converts the heat energy of the steam into mechanical energy. The generator then converts the mechanical energy into electrical power. What is steam generator? These are the basic elements of plant design. The steam generator. It is a combination of apparatus for producing, furnishing, or recovering heat, together with apparatus for transferring to a working fluid the heat thus made available. It indicates also the furnace, the boiler, water walls, water floor, water screen, superheater, preheater, and economizer, also air preheater and fuel burning equipment. The term boiler has been used for such a long period of time that the two terms are used interchangeable. What are steam turbine, or what is the steam turbine? Steam turbine, it is a practical power source when built in as small as a 5 horsepower or as large as 100,000 horsepower. It is relatively quiet and smooth in operation. The condenser, it is a heat exchanger. When steam enters the top and the condensate is collected in the hot well at the bottom while cooling water flows through the tubes. Next is the boiler feed pump or the feed water pumps. It is the function is to increase the function of boiler feed pump is to increase the pressure existing on a liquid and increment sufficient to the required services or service. How it works? Please watch this.
Although power plants may appear complex, the basic processes used to create electricity are surprisingly simple. Let's take a look at how it works. Most power plants generate heat in order to produce steam, which drives turbines that generate electricity. Nuclear fission, natural gas, and coal are the main fuels used in the United States. At Fisk and Crawford, coal is the fuel burned to generate heat. Traditional coal-fired power plants like Fisk and Crawford have two basic components. The first is a furnace boiler, designed to burn coal and capture the resulting heat energy using a system of circulating water and steam. The process starts with the boiler, which is a furnace where combustion takes place. Pulverized coal is injected with a stream of air into the furnace in a continuous process through a device known as a burner. Burners ignite the coal and air mixture, creating a maximum amount of heat possible, as much as 1500 degrees centigrade. The second part of the system is a steam turbine generator, which converts the heat energy captured by the steam into electrical energy. First, the intense boiler heat coming from the furnace turns water running through the pipes around the boiler into steam. The steam travels through more pipes to the turbine, causing it to spin and turn the shaft of the generator, which creates electricity. Another series of pipes allows the steam to cool, condensing back into water heading back to the boiler where the process begins again in a continuous cycle. At Fisk and Crawford, we are proud to provide reliable and affordable power to the people of Chicago.
All right, so that's the simple presentation of on how steam power plant really works on in an industry. So next is what are the types of steam power plant, because we already know what are the functions or how it functions, what are the parts of or the major parts of the steam power plant. So of course we need to determine on where it produces the electricity, or where the steam power plant produces the electricity, saan ba nila ito binibigay yung kanilang electricity na napoprovide. So number one, central station. Ano ba itong central station? The central station, it is the power of this type of power station is produced for sale to the general customers, and it is overall management is vested with a central person, group, or organization. Meaning to say, the central station, it is used for commercial, residential, as long as people buy the electricity. That's a central station. When it comes to industrial power station, it is the type of power station production company generates electricity for its own use, and its output is not sold to the general customers. Meaning to say, it is a private use only when it comes to using of electricity. Like for example, some of the other industrial establishments that needs the high capacity of electricity. So they are more, or they need private, or they need yung sa kanila lang talaga na planta, na yung electricity nila umiikot lang sa kanila. So that's it. It is not for sale for general customers. So the central station is for sale, and then the industrial power station is not for sale. That's the key points. And the steam power plant uses a Rankine cycle. Rankine cycle is the most basic cycle in all power plants. What is Rankine cycle? It is the ideal steam power cycle. This ideal plant consists of a steam generator which receives feed water under the pressure from a pump, a prime mover in which to obtain the working expansion. So yung pump is the prime mover to obtain the expansion of the work of the pressure, and a condenser to reduce the exhaust steam to liquid, and then again ready for pumping. Here's this the diagram of a Rankine cycle. The temperature entropy cycle, with the TS diagram. As you observe, this side will be the sub-cold liquid, and this side is the superheated vapor. And at the center will be the wet region under your curve. And then at the top of your diagram will be the critical point. As you observe, there is 4 points here. So 1, 2, 3, and 4. So that's the cycle. From 1 and 2, meaning to say that that's the constant entropy. That's the quality. From 1 and 2, 1 and 2, that's the constant entropy. And then the S1 and the S2, S1 is equals to S2, meaning to say, what is the value of S1 is the value of S2, meaning to say that's a s-entropic process. And then the S2 is equals to the entropy of saturated liquid plus X, the entropy of evaporation. That's it. So we're going to convert that. So X is equals to entropy sub X minus entropy of saturated liquid over the entropy of saturated vapor minus the entropy of saturated liquid is equals to enthalpy sub X minus the enthalpy of saturated liquid over the enthalpy of saturated vapor minus the enthalpy of saturated liquid. But, sabi niya, but the entropy of the saturated vapor minus the entropy of the saturated liquid is equals to entropy of evaporation. Thus, the enthalpy is equals to the enthalpy of saturated liquid plus the X of enthalpy of saturated, enthalpy of evaporation. So there are many cycles when it comes to steam power plant. One of the cycle is the reheat regenerative cycle. What is reheat regenerative cycle? Reheat regenerative cycle, it is the reheat regenerative steam power cycle increases by its efficiency by increasing the average temperature of heat reception. In spite of such an increment or increase in efficiency, reheating increases the reversibility of feed water heaters by using superheated steam of a greater temperature difference in the regenerative cycle. As you observe here, this is the schematic diagram of the reheat regenerative cycle. Process 1 and 2, this is the process 1 and 2. This will be your reheater and then your boiler. Then also you have two pumps, the open feed water, your condenser, the turbine, and then the generator. Process 1 and 2, which is the partial isentropic expansion, and 2 and 3 will be the intermediate partial isentropic expansion. Ito yan siya, 2 and 3. Papunta ang turbine na siya. So, and 2 and 8, ito, 2 and 8, from 2 down to, punta siya ng open feed water, isobaric heat rejection in heater. So, nire-reject niya ngayon yung heat from heater. And then the 7 and 8, ito, 7 and 8, pasok na siya sa open feed water, goes to pump, back to boiler. Ang tawag dyan is the isobaric heat added in heater. And then the 3 and 4, ito, 3 and 4, from 2 and 3, from the turbine, the exist heat here in the turbine goes to the reheater so that we're gonna add the heat, then back to the turbine. It's called isobaric resuperheating in the reheater. So meaning to say, if your temperature is 100 degrees Celsius or 540 degrees Celsius, it will gonna add up, let's say, times 2. So that's 1,800 degrees Celsius. So reheater, so init ulit. From the waste heat from turbine, nasasaluin na naman siya ulit na mayroong tube, papuntang reheater, na initin ulit, papuntang turbine. And then, at least mag-add power from turbine, at least to produce electricity, goes to the generator. And then the 4 and 5, the complete isentropic expansion. So yung 4 and 5. 4 and 5. Here, 4 and 5. So, pasok dito, ayan, labas, ikot-ikot nyo. Next is the combined gas turbine, or the combined gas turbine steam cycle. It's used, what is this? It is used to transfer the heat carried by the flue gas in the gas turbine cycle, or the exhaust, to the feed water in the steam cycle. And the heat exchanger performs the function of a boiler. The combined cycle power plant is the assembled heat engines that work in tandem for the same source of heat, converting into mechanical energy. On land, when used to make electricity, the most common type called combined cycle gas turbine or CCGT plant. The same principle is also used for marine propulsion, where it is called a combined gas and steam or a co-gas plant. Combining 2 or more thermodynamic cycle improves overall efficiency, which reduces fuel cost. From here, using this schematic diagram is the gas turbine. So we only have one boiler. Yung exhaust ng gas turbine dadaan ngayon sa boiler. So that iinitin itong boiler, tapos itong tube na to, papunta naman siya sa steam turbine. Ayan. So ikot-ikot na siya. 1, 2, 3, and 4. So meaning the bottom line will be the exhaust gas of the gas turbine. Mapupunta ngayon siya sa boiler. And then, merong tube from steam turbine na naman, schematic diagram, ibang diagram naman ito sa schematic diagram of the steam turbine. Isang function lang sila dito. Ipainitin ngayon ni gas turbine, yung exhaust gas, yung boiler, para at least magkakaroon ng magkaka-generate ito ng power papuntang steam turbine para at least ma-provide niya yung need na electricity mapuntang generator, at least para mapaikot siya yung steam turbine. What is the binary mercury steam power plant? It is used to transfer heat carried by the mercury in the mercury vapor cycle to the feed water in the steam cycle. The heat exchanger performs the function of the boiler. Mercury has a much higher boiling point than water. So the Carnot efficiency of the thermodynamic cycle that uses it is higher. In the theory, at least, the plants were dual cycle, also known as the binary cycle. The hot metallic exhaust from the mercury turbines being used to produce steam for a second stage of steam turbines. So it seems like they have similarities when it comes to the combined cycle power plant. The only thing is, sa kabila is mercury ang gamit. So mercury steam, mercury, nakainit is yung mercury kasi mas mataas ang heating value ng mercury. So, yung mercury turbine, generate ng power. So, tapos yung exhaust niya, pupunta ng heat exchanger. Tapos, yung si heat exchangers, ipinin na naman yan ulit. Tapos, transfer na naman sa steam turbine. So, same lang. Tapos, ipapump na naman. So, ito yung energy balance niya. So, heat exchanger, ano heat exchanger? Ito kanina yung ito sa mercury, binary mercury, steam power plant. Ito yung dalawa niya. Ito yung dito sa steam, ito yung sa mercury. So, heat loss by mercury is equals to heat gain by water. Ano yung heat na nawawala sa mercury? Ito naman yung dumadagdag ng init or the heat gained by water. So ito, mm is the mercury flow rate times 2 enthalpy or H over B minus H over C equals to M feed water mass flow rate times 2H sub 1 minus H sub 2, or feed water mass flow rate is equals to steam mass flow rate. Whereas the mercury flow rate is equals to feed water mass flow rate times 2H sub 1 minus H sub 4 over H sub B minus H sub C. Okay, this is also a diagram of the uh, steam steam power plant. So this will be the temperature, and this will be your entropy. So that's called TS diagram. Total heat added, QA is equals to QA sub 1 plus QA sub 2 is equals to Q of the boiler plus Q of reheater. Ito, heat added, Q, or the heat added of the boiler plus the heat added of the reheater, where the total turbine work, or WT, is equals to WT1 plus WT2 plus WT3. So 1, 2, and 3. So merong tatlong work na nangyayari. Kasi nga, merong dalawang heat na nagpo-produce from boiler and then the reheater. From total pump work, ito naman yung pump work, sa WT, dito yung pump na area. Ito pump na ngayon, goes to 7 and 8, goes to 9. Yan. Ang efficiency niya is the total work or the work net over the heat added is equals to total work or the total turbine work or the total minus the total pump work over the heat added total. Additional is the efficiency is equals to Q heat over Q plus QS, or Q is the delta H, and the QS is equals to the total of delta entropy. So let's go to the calculations. I only provide one problem solving. The problem was a reheat steam has 30,850 kilopascal through pressure at the turbine inlet and a 2,800 kilopascal reheat pressure. The throttle and the reheat temperature of the steam is 500 degrees centigrade. Condenser pressure is 3.4 kilopascal. Engine efficiency of a high pressure and low pressure is 75%. Now, find the cycle thermal efficiency. So, our solution is first we need to draw the diagram and then the schematic diagram of the problem. So, from boiler, reheater, and then pump. So, we have the reheat, 2.8. Ito, the turbine inlet, 2.8 MPa at 540 degrees centigrade. Papunta ngayon siya sa low pressure turbine. From boiler, from boiler, we have 13,850 kPa of 540 degrees centigrade goes to high pressure turbine lalabas ngayon siya sa reheater, papasok ngayon siya sa reheater, and then aakyat naman siya. After reheating, meron 2.8 megapascal at 540 degrees centigrade, papasok ngayon siya sa low pressure turbine. And then lalabas ngayon siya dito sa condenser, papasok sa condenser, which is merong water inlet, heat rejection, and then the water out. And then, after that, papasok ngayon siya sa pump, work ngayon siya ng pump para tataas ang pressure ulit. Papasok ngayon siya sa boiler. So, cycle lang siya from 1, 2, 3, 4. 1, from boiler, pasok ngayon siya sa turbine, sa reheater. Pasok naman niya siya sa reheater to low pressure turbine. Lalabas ngayon siya to condenser, papuntang pump, and then to boiler again, and then so on and so forth. First, the value given, we will only see it on this steam table, na thermodynamic table. So at 13.85 MPa and 540 centigrade is our enthalpy 1 equals to 3,434.1 kilojoule per kilogram. At 2.8 MPa megapascal and 540 degrees centigrade is our H3, or the enthalpy sub 3 is equals to 3,548.5 kilojoule per kilogram, whereas our enthalpy 2 at entropy 2 is equals to entropy 1. Meaning to say the entropy 2 and then entropy 1 is the same, and then our enthalpy 2. The value is 6.5436 kilojoule per kilogram. So meaning to say our H2 is 2,974.9 kilojoule per kilogram. So our H4 at entropy 4 is equals to entropy 3, 7.3810 kilojoule per kilogram. Our H4 is equals to 2,204.5. Our H5 is equals to enthalpy saturated liquid at 0.0034 MPa equals to 109.84 kilojoule per kilogram. Our specific volume equals to specific volume of saturated liquid at 0.0034 MPa equals to 0.00132 meter cube per kilogram. So solving for H, so we have the enthalpy A is 6 minus H5 is equals to the specific volume times the pressure, 6 minus pressure sub 5. So substitute the value of H5 and then the specific volume and then the pressure. So H sub 6, or the enthalpy 6 minus 109.84 is equals to 0.001032 times the 13,850 minus 3.5. Our H6 is equals to 123.73 kilojoule per kilogram. Our total work is equals to enthalpy 1 minus enthalpy 2 plus enthalpy 3 minus enthalpy 4 multiplied by the percentage, or the pressure. The engine efficiency of high pressure and low pressure is 75%. The engine efficiency pressure. Turbine work. So substitute the value of enthalpies. So the total turbine work is 3,434.1 minus 2,974.9 plus 3,000 548.5 minus 2,204.5 times the efficiency of the engine, the lower pressure and the low pressure and the high pressure of 75% is equals to 1,352.4 kilojoule per kilogram. So sa pump work naman tayo, let's go proceed to the pump work. So the enthalpy sub 6 minus enthalpy sub 5. So pump work, substitute na natin yung value niya is 1,123.73 minus 109.84. Ang total pump work niya is 13.89 kilojoule per kilogram. The heat added. So the heat added 3,434.1 minus 123.73 H1 plus 3,540.5 minus 2,974.9. Our heat added is equals to 3,883.97 kilojoule per kilogram. Thus, our efficiency, na ito yung hinahanap natin, is the total turbine work minus the total pump work over the heat added, total heat added, is equals to 1,352.4 kilojoule per kilogram minus the 13.89 kilojoule per kilogram over our heat added of 3,883.97 kilojoule per kilogram. Our efficiency is equals to 34.46%. So that's it, and thank you.